Hello everyone, welcome back to our channel. Today we are going to discuss about very important question for final exams from the first year physics. The question name is, show that the projection of uniform circular motion is the simple harmonic motion. And one more type they are asking based on this, define the simple harmonic motion. If the particle is projected and it is having the circular motion, means that is also having the simple harmonic motion, we have to prove that one. For this, it is having the circular motion, means we should draw one circle and consider two reference diameters. One is the y dash y, another one is the x dash. Before that, what is the simple harmonic motion? If the acceleration is directly proportional to the displacement, when the body is having the periodic motion, is called the simple harmonic motion. Where we should observe that simple harmonic motion? Already I said in previous classes, when earth is revolving around the sun, and in the case of swing also, in our lab simple pendulum, all belongs to simple harmonic motion. So if you say the body is having the simple harmonic motion, we must show this relation. It is must be having the periodic motion and acceleration is directly proportional to displacement. Here A belongs to acceleration, Y belongs to displacement. Negative sign is representing both are having the opposite direction. If the body is having the periodic motion and that too acceleration is directly proportional to displacement, that motion is called the simple harmonic motion. If you are writing that, you will get 2 marks. The next part of this one, yes, here the particle is projected and this is having which motion? Uniform circular motion. And we consider omega is the angular velocity and the particle P is here. We are drawing the normal to the surface N. From O to N we consider the distance is y. It will make an angle theta here. Theta is the angular displacement and radius of circle is nothing but amplitude in this case, because maximum displacement of vibrating particle, oscillating particle in circular motion, radius we should consider as a amplitude. So from here to here the distance is amplitude A. In previous chapter system of particles, what is the angular displacement formula? Theta equals to omega into t. Angular displacement equals to angular velocity into t, because it is having the circular motion. In circular motion, angular velocity is omega. Here time is, we should consider t seconds. Theta is the angular displacement. Now come to this figure. Here the particle P is here. Suppose if it is moving from y dash to y, means it is going upward direction. Just you look this marker, this is like normal. So when it is moving from y dash to y, this is going upward, this normal. When the particle is coming y to y dash, that too should consider this is the anti-clockwise direction. Then it is coming downwards. So clearly it is having to and fro motion, means it is repeating its motion in equal intervals of time. So it is the periodic motion. The next thing we have to prove that acceleration is directly proportional to displacement. For this, first we derive the expression for displacement, then we derive the expression for velocity, then we can go through the acceleration. Displacement of this particle. Displacement we are representing with y. From figure or from triangle OPN, we can take sin theta equals to opposite by hypotenuse, y by radius of this one is amplitude. When we do the cross multiplication, y equals to a sin, instead of theta we are writing omega t. This is the expression for displacement. Then we focus on velocity. If you know the displacement, how to find out the velocity? The rate of change of displacement is called the velocity. So v equals to dy by dt. Instead of y we should write it a sin omega t, but a is constant, so v equals to a into differentiation of sin omega t formula is omega cos omega t. This is the expression for velocity. When we know the velocity, we can find out the acceleration. What is the relation between them? Rate of change of velocity is called the acceleration. So A equals to dv by dt. A equals to d by dt of a omega cos omega t. Here this is having the uniform angular velocity and amplitude is also constant. So A equals to, we can't apply the differentiation to A omega. A omega d by dt of cos omega t. D by dt of cos omega t formula is minus omega sin omega t. But from this equation, instead of A and sin omega t, we should write the y, and omega into omega, omega square. Here minus is coming to front, minus omega square y. So from this clearly we can say that acceleration is directly proportional to displacement. It shows simple harmonic motion. So this is very important for final exams. When you know the displacement, we can find out the velocity. And when we know the velocity, we can find out the acceleration. Why we are doing these expressions till acceleration in S.H.M? Any particle is having the simple harmonic motion means we must show that acceleration is directly proportional to displacement. Thank you.